So this lesson is looking at comparing the three different types of functions that we've learned about in Math 1. The first was linear. We spent a good amount of time on that. You also came in from 8th grade having learned a lot about linear. Remember, the equation is y equals mx plus b. That's slope-intercept form. The y values, the y's are either adding or they are subtracting by a constant number. And then in the calculator, what you did was stat calc 4 to get your equation. Okay, so that again is linear. Our exponential function, the equation is y equals a times b to the x power. The x is the exponent in exponential. Hopefully you'll remember the y's are multiplying. They're not dividing, although it may look like it's dividing when it's multiplying by a fraction, but it's multiplying by a constant number. And in the calculator, if you have a table and you get an equation, you're doing stat calc 0. Okay, and maybe it's helpful to, draw a little picture. Well, that kind of almost looks linear. There we go. So straight lines for linear, curved lines for exponential. And then for quadratic, our equation, our parent equation anyway, is y equals ax squared plus bx plus c. And now this is what we're really getting ready to look at. We've already compared linear and exponential in a previous lesson after we learned exponential stuff. So for quadratic, it's going to be, this is what we're kind of the new thing that we're looking at. For these, our y's, second difference, okay? Second difference is the same, and you'll see what that looks like in just a second. In the calculator, we do stat calc 5, and the graph either smiles up as a parabola or frowns down as a parabola. So that's just to remind you the basic things that we've learned, the very basic things that we've learned about each of those types of functions. And the examples that we're going to look at are deciding, okay, well, which type of function best represents the data. So you could put this into, Desmos and look to see if you can kind of guess. But remember, you're only given a piece of the data. You're only given small pieces. You're not given the whole thing. So even if you just got dots on your graph, you're not going to see a true picture for what the whole graph looks like. Okay? So instead, you can either look at without a calculator, you can look at your y values to see, can I see something that's consistent or constant that's happening here? Sometimes you can and sometimes you can't. We'll show you how to do it in the calculator as well. But starting with number 1, if you're looking at the y values, from -4 to -1, I'm going up 3. From -1 to 2, I'm also going up 3. And from 2 to 5, I'm going up 3. This is an easy one. You can see since it's adding by the same number, it's going to be a linear function. All right. In the calculator, you would need to check, stat calc 4, stat calc 5, stat calc 0, with the diagnostic on. So let's actually make a note of that. So in the calculator, we need to turn the diagnostic on. There we go. Okay, so to do that, remember you were hitting second, 0, and then you're going to scroll down, and then click enter once you get it. You want to look at r, at the bottom r. Okay, I think it actually is r squared for quadratic. And you want what is closest to -1 or +1. Okay, whatever one is closest will be that function that would be best. All right, so moving on to number 2, looking at your y values. If we didn't have a calculator, you're looking at the y values. So notice, okay, so I'm going from 4 to 9, I'm going up 5, up from 9 to 16, I'm going up 7, from 16 to 25, I'm going up 9. Okay, so this obviously means that it's not going to be linear, because I do not add by the same number each time. This is called the first difference. All right, and then the quadratic thing is next. Okay, so watch what happens now. If I then try from the first difference to see how it changes, from 5 to 7, I go up 2, and from 7 to 9, I go up 2. This is the second difference. And if the second difference is the same, we said then it's going to be quadratic. Okay. 3, again, you could try it in the calculator, but we're looking without right now. From 1 to 2, I add 1. 2 to 4, I add 2. 4 to 8, I add 4. Okay, so that's not multiplying. I'm looking at the second difference. This is still going up 1. This is going up 2. So the first difference means it's not linear. It's not linear. The second difference is not the same, so it's not quadratic. So likely it's going to be exponential, and let's double check what that looks like. From 1 to 2, I multiply by 2. From 2 to 4, I multiply by 2. And from 4 to 8, I multiply by 2. So since we're multiplying by 2, it's exponential. And then the last one, it'd be really great if you tried it in the calculator, checking StatCalc 4, StatCalc 5, and StatCalc 0. So for linear, if I did StatCalc 4, the R is 0.88. Again, I don't have a document camera, so I can't show you me doing this, but I'm doing StatCalc and then checking each 4, 5. The quadratic is 1. Ooh, so that's perfect, probably quadratic. And your exponential, the R, is 0.89. So they're all really strong, but the best fitting function is quadratic.